Good morning all. So in today's class we will see finding eigenvalues and eigenvectors. So we will see for 2 by 2 and then 3 by 3 matrix. So find the characteristic values and characteristic vectors of the matrix. So we have the matrix A equal to 1, 2, then 3, 2. So the characteristic equation is, so that is determinant A minus lambda I equal to 0. So that is determinant of 1 minus lambda 2, then 3, 2 minus lambda equal to 0. So that gives 1 minus lambda into 2 minus lambda minus 6 equal to 0. So you will get 2, then minus 3 lambda plus lambda square minus 6 equal to 0. So the equation is lambda square minus 3 lambda minus 4 equal to 0. So that gives lambda minus 4 into lambda plus 1 equal to 0. So the roots are going to be 4 and minus 1. So the required characteristic values are, so that is lambda equal to 4 and minus 1. Now let us take the case when lambda is equal to 4. So when lambda equal to 4, so when you take the equation ax equal to 4x, so that gives, so you have 1, 2, then 3, 2, x equal to 4x. So taking it to the left side, so you will get 1 minus 4 over for matrix will be A minus lambda I. So that will be minus 3, 2, then 3, 2 minus 4 is again minus 2, x equal to 0. Now let us reduce the matrix. So you have minus 3, 2, then 3 minus 2. So if you take R2 goes to R2 plus R1. So the matrix will reduce to minus 3, 2. Then this becomes 0. So therefore the equation becomes, so you will get minus 3, 2, 0, 0, x1, x2 equal to 0. So it will reduce to a single equation. So you have 3x1 plus minus 3 minus 3x1 plus 2x2 equal to 0 So this is one equation and two unknowns, so it will have infinitely many solutions. So put x1 equal to t, then x2 will be equal to 3x1 by 2. So that is 3t by 2. So therefore the required eigenvector is, so let me call it as x1. So the eigenvector is going to be 3 and 3t by 2. Or you can also, if you multiply it with 2, or you can write it as 2t and 3t is the characteristic vector. So this is the corresponding eigenvector corresponding to lambda. And similarly, when lambda is equal to minus 1, so A minus lambda I x equal to 0 implies So you will get 1 minus minus 1. Appa 2 varum. Then 3, 2 minus minus 1, 3, x equal to 0. So equivalently, so this is equivalent to okay, I can write as 1 1 0 0 x equal to 0. നമ്മൾ matrix row eliminate ചെയ്യുക, then that will be equivalent to this form. So you will get the equation x1 plus x2 equal to 0. So put x2 equal to t. So x1 will be equal to minus t. So therefore the eigenvector is, so we will get minus t and t. So that is the corresponding eigenvector. So eigenvalues are, or characteristic values are 4 and minus 1, and the corresponding eigenvectors are, so the first vector will be, so I can write it as നമുക്ക് കിട്ടിയത് 2 3യുടെ any multiple of 2 3. So we will ignore that t. So I will write just the vector 2 3. So any multiple of 2 3 is also going to be an eigenvector. Then minus 1 1. Neither minus 1 1 no allengi 1 minus 1 no vara. Then this is again 1 3 by 2. All are equivalent. കാരണം ഇതിനെല്ലാ constant multipliers എടുക്കുമ്പോഴും നമുക്ക് eigenvalues ആണ് കിട്ടുന്നത്. So next we'll see one more problem. So we'll see a 3 by 3 matrix. So find the characteristic values. And characteristic vectors of the matrix A equal to minus 7, minus 1, 6, then minus 10, 4, minus 12, then minus 2, 1, minus 1. So let us take determinant of A minus lambda equal to 0. So the characteristic equation is determinant of A minus lambda equal to 0. So you get 7 minus lambda minus 1 6, then minus 10, 4 minus lambda minus 12, then minus 2 1, minus 1 minus lambda equal to 0. So I am not doing the simplification, so I leave it to you. So I'm just going to write the cubic equation. So you'll get lambda cube minus 10 lambda square plus 31 lambda minus 30 equal to 0. So you can solve this using calculator. Cubic ആണ്, അപ്പം calculator വെച്ചിട്ട് solve ചെയ്യുക. So the roots are going to be lambda equal to 2, 3 and 5. So these are the characteristic values. And let us see the characteristic vector corresponding to lambda equal to 2. So when lambda equal to 2, you have a minus 2i x equal to 0. So a minus 2i x equal to 0 will be, so take, subtract 2 from the diagonal element. So you will get minus 5, 1 6, then minus 10 2, then minus 12, then minus 2 1 and minus 3 there. Okay. Now let us solve for this equation. Now when you solve for the equation, okay, x equal to 0, let us simplify, row reduce the matrix. So So 5 minus 1, 6. Then you have minus 10, 2, minus 12, then minus 2, 1, minus 3. So take R2 goes to 2R1 plus R2. So that gives 5 minus 1, 6. So this is a multiple of the first row. So we'll get 0, 0, 0. Then minus 2, 1, minus 3. And now using the first two equations, okay, so you can simplify it again. So take the first equation. Okay, you can add the first equation. So you can take R1 goes to R1 plus R3. So that gives 3, 0, 3. Then 0, 0, 0. Then minus 2, 1, minus 3. So I can again take R1 goes to R1 by 3. So that gives 1, 0, 1, 0, 0, 0. Then minus 2, 1, minus 3. Now here I can make it 0. Minus 2 in the place there. So I can take R3 goes to 2, R1 plus R3. So that will give us 1, 0, 1, 0, 0, 0. Then it is 0 varum. Then 1. Then 2 times R1 plus R3 minus 1. Now, okay, let us now write the equation. So you will get x1 plus x3 equal to 0 varum. Then x2 minus x3 equal to 0. So if I take x3 equal to t, I am going to get x1 equal to minus t and x2 will be equal to t. So the required eigenvector is minus 1, 1, 1. Okay, so the eigenvector is minus 1, 1, 1. So that is the eigenvector corresponding to lambda equal to 2. Now let us take lambda equal to 3. So when lambda equal to 3, again take the matrix A minus 3i x equal to 0. So that will be A minus 3 edukkumbo, you will get 4 minus 1 6, then minus 10 0, minus 12, minus 2 1, minus 4 varum. So x equal to 0. So that is the required system. Now again we need to row reduce that. Row reduce here. Sorry, this is 1. 4 minus 3 11. 1 varum. Okay, so this is the matrix. So you have 4 minus 1 6 and minus 10 1 minus 12 minus 2 1 minus 4. So take R1 goes to 2 R3 plus R1. So that will give 0 and 2 minus 1 1 varum. Then minus 8 plus 6 minus 2. Again you have minus 10 1 minus 12 minus 2 1 minus 4. And again take R2 goes to minus 5 R3 plus R2. So 10 ന്റെ place 0 ആവും. So we'll get 0, 1, minus 2, then minus 2, 1, minus 4. So